Hi students, welcome to lesson number 31, data sources, classification and tabulation, frequency distribution. Let us start with the introduction. The data collected for the purpose of a statistical inquiry sometimes consist of a few fairly simple figures which can be easily understood without any special treatment. But more often there is an overwhelming mass of raw data without any structure. Thus, unwieldy, unorganized and shapeless mass of collected is not capable of being rapidly or easily associated or interpreted. Unorganized data are not fit for further analysis and interpretation. In order to make the data simple and easy understandable, the first task is not condense and simplify them in such a way that irrelevant data are removed and their significant features are stand out prominently. The procedure adopted for this purpose is known as method of classification and tabulation. Classification helps proper tabulation. Start with the objectives. After studying this lesson, the student should be able to classify a data set according to the nature of data, construct a discrete frequency distribution for a discrete type of data, construct a continuous frequency distribution for a continuous type of data, classify the collected data according to the class intervals and arrange the data into a suitable form of a table. Let us start with the classification of data. After collection, classification is the next step in processing collected data. Classification means grouping of related facts into different classes. Meaning of classification. Classification is a process of arranging things or data in groups or classes according to their resemblances and affinities and gives expressions to the unity of attributes that may be subsist among a diversity of individuals. Let us look into the definition of classification. Classification is the process of arranging data into sequences and groups according to their common characteristics or separating them into different but related parts. The process of grouping large number of individual facts and observations on the basis of similarity among the items is called classification. Stockton and Clark. Characteristics of classification. A. Classification performs homogeneous grouping of data. B. It brings out points of similarity and dissimilarities. C. The classification may be either real or imaginary. D. Classification is flexible to accommodate adjustments. The objectives or purposes of classification: to simplify and condense the large data, to present the facts easily in understandable form, to allow comparisons, to help to draw valid inferences, to relate the variables among the data, to help further analysis, to eliminate unwanted data, to prepare tabulation. The guiding principles or the rules of classification. Following are the general guiding principles for good classifications. A. Exhaustive. Classification should be exhaustive. Each and every item in data must belong to one of class. Introduction of residual class, that is either miscellaneous, etc., should be avoided. B. Mutually exclusive. Each item should be placed at only one class. C. Suitability. The classification should conform to object of inquiry. D. Stability. Only one principle must be maintained throughout the classification and analysis. E. Homogeneity. The items included in each class must be homogeneous. F. Flexibility. A good classification should be flexible enough to accommodate new situation or changed situations. Types of classification. Types of classification refers to the class categories into which the data could be sorted out and tabulated. These categories depend on the nature of data and purpose for which data is being sought. The important types of classification: geographical, on the basis of area or region wise; B. chronological, on the basis of temporal or historical, that is with respect to time; C. qualitative, on the basis of character or attributes; D. numerical, quantitative, on the basis of magnitude. The geographical classification. In geographical classification, data are classified on the basis of location or region, etc. For example, if we present the data regarding production of sugarcane or wheat or rice in view of the 4 main regions in India, this would be known as geographical classification. Geographical classification is usually listed in alphabetical order for easy reference. Items may also be listed by size to emphasize the magnitude of the areas under consideration, such as ranking the states based on population. The chronological classification. Classification of data observed over a period of time is known as chronological classification. Qualitative classification. In qualitative classification, data are classified on the basis of some attributes or qualitative characteristics such as sex, color of hair, literacy, religion, etc. You should note that in this type of classification, the attribute under study cannot be measured quantitatively. One can only count it according to its presence or absence among the individuals of the population under study. For example, in case of color blindness, we may find out as how many persons are color blind in a given population. It is not possible to measure the degree of color blindness in each case. Thus, when only one attribute is studied, 2 classes are formed, one for possessing the attribute and the other for not possessing it. This type of classification is known as simple classification. For example, the population under study may be divided into 2 categories based on the characteristic color blindness as follows. In a similar manner, we may classify population of a colony on the basis of education qualification, employment, sex, etc. This type of classification where 2 or by 2 classes are formed is called twofold or dichotomous classification. If instead of forming only 2 classes, we further divide the data on the basis of some other attributes within those attributes is known as manifold classification. For example, we may first divide the population into 2 men and women on the basis of the attribute sex. Each of these classes may be further subdivided into literate and illiterate on the basis of attribute. Further, it may be classified as a simple classification, manifold classification, simple classification if the classification is done into only 2 classes, example, a population into male or female. The manifold classification. In this classification, the classification is based on more than one attribute at a time. Quantitative classification. In quantitative classification, the classification is based on quantitative measurements of some characteristics such as age, marks, income, production, sales, etc. The quantitative phenomena under study is known as variable, and hence this classification is also called as classification by variable. For example, marks or number of students: 0 to 10, 5 students, 10 to 20, 7 students, 20 to 30, 10, 30 to 40, 25, 40 to 50, 3, total 50. In this classification, marks obtained by students is variable and number of students in each class represents the frequency. The frequency distribution. Frequency distribution is a table used to organize the data. The left column called classes or groups includes numerical intervals on a variable under study. The right column contains the list of frequencies or number of occurrences of each class or group. The intervals are normally of equal size covering the sample observations range. It is simply a table in which the gathered data are grouped into classes and the number of occurrences which fall in each class is recorded. The definition: according to Croxton and Crowden, a frequency distribution is a statistical table which shows the set of all distinct values of the variable arranged in order of magnitude, either individually or in groups with their corresponding frequencies. According to the nature of variable, the frequency distribution may be classified as series of individual observation, discrete frequency distribution, continuous frequency distribution, relative and cumulative distribution. Let us discuss them one by one. Series of individual observation. Series of individual observation is a series where the items are listed one after each observation. For statistical calculations, these observations could be arranged in either ascending or descending order. This is called as array. Discrete frequency distribution. A frequency distribution in which the information is distributed in different classes on the basis of discrete variable is known as discrete frequency distribution. The continuous frequency distribution. A distribution in which the information is distributed in different classes on the basis of a continuous variable is known as continuous frequency distribution. The continuous data series is one where the measurements are only approximations and are expressed in class intervals within certain limits. In continuous frequency distribution, the class interval theoretically continues from the starting of the frequency distribution till the end without break. According to Boddington, the variable which can take very intermediate value between the smallest and largest value in the distribution is a continuous frequency distribution. Relative frequency distribution. A relative frequency distribution corresponding to a class is the ratio of the frequency of that class to the total frequency. The corresponding frequency distribution is called relative frequency distribution. If we multiply each relative frequency by 100, we get the percentage frequency corresponding to that class, and the corresponding frequency distribution is called percentage frequency distribution. The cumulative frequency distribution. The cumulative frequency of a class is the total of all the frequencies up to n and including that class. A cumulative frequency distribution is a frequency distribution which shows the observations less than or more than a specific value of the variable. The number of observations less than upper class limit of a given class is called less than cumulative frequency, and the corresponding cumulative frequency distribution is called less than cumulative frequency distribution. Similarly, the number of observations corresponding to the value of more than the lower class limit of a given class is called more than cumulative frequency, and the corresponding cumulative frequency distribution is called more than cumulative frequency distribution. Classification according to class intervals. To make data understandable, data are divided into number of homogeneous groups or subgroups. In classification, according to class intervals, the observations are arranged systematically into a number of groups called classes. Such classification is most popular in practice, but before this discussion, we have to define some terms which will be used in the above classification. 1. Class limits. The class limits are the lowest and the highest values of a class. For example, let us take the class 10 to 20. The lowest value of this class is 10 and the highest 20. The two boundaries of a class are known as the lower limit and the upper limit of the class. The lower limit of a class is the value below which there cannot be any value in that class. The upper class limit of a class is the value above which no value can belong to that class. 2. Class intervals. The class interval of a class is the difference between the upper class limit and the lower class limit. For example, in the class 10 to 20, the class interval is 10, that is 20 minus 10. This is valued in the case of exclusive method discussed in this subsection later on. If the inclusive frequency distribution discussed later on in this subsection is given, then first it is converted to exclusive form and then class interval is calculated. The size of the class interval is determined by number of classes and the total range of data. 3. Range of data. The range of data may be defined as the difference between the lower class limit of the first class interval and the upper class limit of the last class interval. 4. Class frequency. The number of observations corresponding to the particular class is known as the frequency of that class or the class frequency. 5. Class mid value. It is the value lying halfway between the lower and upper class limits of class interval. The mid value of each class is taken to represent that class. Now, we are in position to discuss the two methods of classification according to class intervals, namely exclusive method and inclusive method. Let us discuss these two methods one by one. Exclusive method. Under this method, a class interval is such that each upper class limit is excluded from the class interval. Here in this method, class intervals are so fixed that upper class of one class is the lower limit of the next class. In the following example, there are 24 students who have secured the marks between 0 and 50. A student who secured 20 marks would be included in class 20 to 30, not in 10 to 20. This method is widely followed in practice. The inclusive method. Under the inclusive method of classification, both lower class limit as well as the upper class limit is included in that class itself. That means, if data are classified in such a way that the lower class as well as the upper class limits are included in the same class interval, it is called inclusive class interval. The remark: 1. Lower limit of a class interval is always included in the class in both the method discussed above. In exclusive method, upper limit of a class is not included in the class. That is why the name exclusive. 3. In inclusive method, upper limit of a class is also included in the class. That is why the name inclusive. The principles of classification. It is difficult to formulate any hard and fast rule for classifying the data. However, the following general considerations may be considered for ensuring meaningful classification of data. 1. The whole data should be preferably divided into number of classes between 5 and 15. However, there is no rigidity about it. The classes can be more than 15 depending upon the total number of observations and variations between them and the details required for given data, but they should not be less than 5, because in that case the classification may not reveal the essential characteristics. To determine the approximate number of classes k, the following formula is suggested by Strux. K equals 1 plus 3.322 log n, where k equals the approximate number of classes, n equals total number of observations, log equals the natural logarithm. However, the appropriate number of classes to be taken for a given data depends upon the personal judgment and other considerations such as range of data, total number of observations, etc. 2. One should avoid odd values of class intervals as far as possible, example 3, 7, 11, 26, 39, etc. One should prefer 5 or 10 or multiple of 5 or 10 as class intervals, such as 5, 10, 20, 25, 100, etc. Because the human mind is accustomed more to think in terms of certain multiples of 5 or 10. 3. The lower class limit of the first class of a frequency distribution should either be 0 or 5 or multiple of 5. For example, if the lowest value of the data is 26 and we have taken a class interval of 5, then the first class should be 25 and 30 instead of 26 and 31. Similarly, if the lowest value of the series is 43 and the class interval is 5, then the first class should be 40 to 45 in spite of 43, 48. 4. To maintain continuity and to get correct class interval, we should adopt exclusive method of classification. However, where inclusive method has been adopted, it is necessary to make an adjustment to determine the correct class interval and to maintain continuity. The intervals of all the classes should be of the same size, because if the class intervals are not of the same width, it is difficult to make meaningful comparison between classes. Sometimes the data may require the inclusion of so many class intervals that the frequency distribution will become large. Then the classification may be done as follows below: 10, 10 to 20, 20 to 30, 30 to 40 and above 40. These classes are called open end classes and the distribution is known as open end frequency distribution. It may be noted that the frequency distributions, like other types of data presentation, are always constructed to serve some specific purpose. The technical requirements outlined above must be supplemented by sound subjective judgments if proper frequency distribution are to be formed. Tabulation of data, meaning and definition of tabulation. Tabulation may be defined as systematic arrangement of data in columns and rows. It is designed to simplify presentation of data for the purpose of analysis and statistical inferences. The major objectives of tabulation: 1. To simplify the complex data, 2. To facilitate comparison, 3. To economize the space, 4. To draw valid inferences or conclusions, 5. To help further analysis. Let us look into the differences between classification and tabulation. 1. First, data are classified and presented in tables. Classification is the basis for tabulation. 2. Tabulation is a mechanical function of classification because tabulation classified data are placed in rows and columns. 3. Classification is a process of statistical analysis, while tabulation is a process of presenting data in suitable structure. The components of a table. The various components of a table may vary case to case depending upon the given data, but a good table must contain at least the following components: 1. The table number, 2. Table heading, 3. Caption, 4. Stub, 5. Body of table, 6. Headnote, 7. Footnote. Let us throw some light on these components one by one. 1. Table number. A statistical table should be numbered. There are different ways with regard to the place where table number is to be given. The table number may be shown either in the center at the top above the title or in the left hand side of the table at the top. When there are many columns, it is desirable to number each column so that easy reference to it is possible. 2. Table heading. A good table should have a suitable heading. The heading is brief description of the contents of the table. It should be placed above the table. It should answer the following questions: A. What categories of statistical data are shown? B. Where the data occurred? C. When the data occurred? In other words, the heading of the table should be clear, brief and self-explanatory, but sometimes long title may have to be used for the sake of clarity. The title should be so worded that it permits only one interpretation. 3. Caption. Caption refers to the column heading and explains what information column presents. It may consist of one or more column headings. That is, under a column heading there may be two or more subheadings. The caption should be clearly defined and placed at the middle of the column. If the different columns are expressed in different units, the unit should be specified along with the captions. 4. Stub. The stubs are rows headings. They are placed at the extreme left of the table and perform the same function for the horizontal rows in the table as the captions. Captions do for the vertical columns. 5. Body. The body of the table is the central part of the table that contains the numerical information presented in table. This is the most vital part of the table. 6. Head note. Head note is a brief explanatory statement applying to all or a major part of the material presented in the table and is placed below the title entered and enclosed in brackets. It is used to explain certain points relating to the whole table that have not been included in the title nor in the captions or stubs. For example, the unit of measurement is frequently written as the head notes, such as in thousands or million tons or in crores, etc. 7. Footnote. Anything in a table which the reader supposed to find difficult to understand should be explained in footnotes. Footnotes may be placed directly below the body of the table. The footnotes are generally used for the following purposes: A. Any special circumstances affecting the data, for example, strike, fire, etc. B. To clarify anything in the table. C. To give the source in case of the secondary data. If any information in the table obtained from some journal, its name, data, date of publication, page number, table number, etc. should be mentioned so that if the user wishes to check the data from the original source, he could know where to look for the information. Types of tables. Tables may broadly be classified into following categories: 1. Simple and complex tables. 2. General purpose and special purpose tables. 1. Simple and complex tables. The simple and complex tables can be differentiated on the basis of number of characteristics presented and studied. If the data based on one characteristic is presented, the table is known as simple table. The simple table is also known as one-way table. On the other hand, in a complex table, two or more characteristics are presented. The complex tables are frequently used in practice because they facilitate to incorporate full information and a proper consideration of all related facts. If the data are tabulated on the basis of only two characteristics, then the table is known as two-way table. If three characteristics are arranged in a table, then the table is known as triple table. When four or more characteristics are simultaneously presented, it is known as manifold tabulation. Two-way table shows two characteristics and is formed when either the stub or the caption or both are divided into two categories. The higher order table. When three or more characteristics are represented in the table, then such a table is called higher order table. The need for such a table arises when we are interested in presenting three or more characteristics simultaneously. It should be remembered that as the number of characteristics increases, the table becomes more and more conducive. It is advised normally not more than 4 characteristics should be represented in the same table. When more than 4 characteristics are to be represented, we should form more than one table, the depicting relationship between different attributes, etc. 2. The general purpose and special purpose tables. General purpose tables, also known as reference tables or repository tables, and provide the information for general use or reference. They usually contain detailed information and are not used for specific discussion. In other words, these tables serve as a repository of information and are arranged for easy reference, such as the tables published by government agencies, the tables contained in the statistical abstract of the Indian Union, the tables in the census reports, etc. The general tables tell facts which are not for particular discussion. If general tables are used by a researcher, they are usually placed in the form of appendix at the end of the report for easy reference. Special purpose tables, also known as summary tables or analytical tables, provide information for particular discussion. These tables are also called derivative tables since they are often derived from general tables. A special purpose table should be designed in such a way that a reader may easily refer to in the table for comparison, analysis or emphasis concerning the specific discussion. The basic principles of tabulation. 1. Tables should be clear, concise and adequately titled. 2. Every table should be distinctly numbered for easy reference. 3. Column headings and row headings of the table should be clear and brief. 4. Units of measurement should be specified at appropriate places. 5. Explanatory footnotes concerning the table should be placed at appropriate places. 6. Source of information of data should be clearly indicated. 7. The columns and rows should be clearly separated with dark lines. 8. Demarcation should also be made between data of one class and that of another. 9. Comparable data should be put side by side. 10. The figures in the percentage should be approximated before the tabulation. 11. The alignment of the figures, symbols, etc. should be properly aligned and adequately spaced to enhance the readability of the same. 12. Abbreviations should be avoided. Now, let us sum up. Statistics is the branch of mathematics concerned with collection, classification, analysis and interpretation of numerical facts for drawing inferences on the basis of their quantifiable probability. It can be interpreting aggregates of data too large to be intelligible by ordinary observation because such data tend to behave in the regular predictable manner. However, the numerical figures called data obtained by counting or measurement, it means collection, classification, presentation, analysis, comparison and meaningful interpretation of raw data. Wherever in advance phenomena numbers of researcher were used advanced tools of statistics with systematic manner. In addition, the efficient functioning of various classification and tabulation tactics is shown in this lesson. Here, various methods of classification and tabulation has been discussed in detail. The major prominence of this lesson is on discussing statistical data classification and tabulation with suitable examples.